Welcome back. This is the second lesson recording for IM1, April 30th, 2021. Now we're going to try to name angles based on measurements. What do we call an angle that is less than 90 degrees, smaller than 90 degrees? Okay, it starts with the A. Okay, what do we call that? It's called acute. So cute. It's a little. It's a cute angle. What about angles that are bigger than 90 degrees? It is obtuse. It's the bigger than 90 degrees called obtuse angle. What about an angle that is 90 degrees exactly? What do we call that? It is the right angle. And what do we call this angle that is formed by a straight line? Okay, so that is angle that is 180 degrees because this is 90 degrees, so on the other side is also 90 degrees. It's going to be 180 degrees. We call that straight line angle because it is from a straight line. So it's a straight angle. It's not a very common term that you use, but you're going to come across that a lot. So you're going to work on card number 10 to 13 of Desmos, please. Okay, so here we are asked to color in the obtuse angle. If I'm talking about this opening here, angle measure, this is smaller than 90 degrees. Obtuse angle is an angle that is bigger than 90 degrees, so it has to be this angle here. Okay, so that's the angle measure we're dealing with. Color in straight angle, so we want a 180 degree angle. Okay, so what is the angle that is forming 180 degrees? It's this side, that's 180 degrees. Okay, color in an acute angle. Well, in a triangle, we have, what does this square mean? It means this is 90 degrees. This is 90 degrees. So this is not acute angle. We want, this is a right angle. Which is the acute angle? Angles that are smaller than 90 degrees. You could have said this is acute angle here. Color that in. Or you could have also said this is an acute angle. Okay, so this is yet a different angle, but this is also acute. Either of them would have been fine. Okay, which is the color in the right angle? Which is the right angle? That's 90 degrees. This is my right angle. So this is 90 degrees. And now we are going to, gone too far. Okay, now we're going to be working on card number 14 to 18. Here we go. Now we're going to, so we have a triangle now. You know how to measure angles like this. So you need to measure each of the vertex angles. So when you're talking about measure of angle H, where is H? The vertex H is there. So we're looking for this angle measure here. So to do that, I am going to move my protractor to match up to the center, like so. I need to line up the bottom of the protractor with the line perfectly, right on. And then again, remember, I'm always going to be measuring up, okay, never down. If I start measuring using the outside numbers, that's going to be measuring from 187 going down. We don't want that. We want to be going up, so we need to be using the inside numbers. So that's 10, 20, 30, 40, and it's more than 40, but less than 50, and it looks like about 44 to me. 44, 45. Yes, I can say 45. Okay, actually, it's not complete yet, so that's part of the reason. Okay, so then what about angle E? Okay, so now this time I am going to move that to the vertex E so that I could measure. Okay, so this is a little bit off. Okay, and now do you notice that the protractor is not lined up properly? So I need to move that so that it does line up perfectly. Here we go. Okay, so I have two options. I can move this to line up like this, and then I'm going to be using the outside numbers, or I can move the vertex so that it is measuring from the inside numbers. Up to you. Okay, so I'm going to go from here. And what do I have? I'm going to be using the inside numbers. So I have 40, it's between 40 and 50. And looking at this number, I see 47. Okay, it's like 3 away from the 50 line, 3 units, so it's going to be 47. So I count 47 here. And then I need to measure angle Y. So I'm looking for this angle here. So I am going to move the center of the protractor to be at Y. Okay, and then here we go. So line up the bottom. Okay, again, I want to be measuring from the inside line because I need to be counting from 0. 0, 10, 20, 40. Okay, so it is less than 90. What would you say is the angle measure here? Okay, so it's less than 90, maybe by about 2. So I'm going to say 88. Now okay, now it's giving me, it's awesome. Okay, so that means all my numbers are pretty accurate. So you do the same thing with another triangle here. Again, triangle vertex H. You need to line it up here. Okay, and then we go line up the bottom perfectly. So then again, I'm going to be using the inside numbers so that I can count up 10, 0, 10, 20, 30, and it looks about 33 to me here. Okay, now that's we need to find the angle measure of A. So put it on the vertex right there. Okay, and then, all right, so is it lined up? Oh, it's lined up already. Okay, so now we arc. So we don't want the inside numbers because if I'm doing the inside numbers, the shaded part is going down. Okay, so we want the shaded part to be going up. So that's going to be outside numbers. And I count between 100 and 110. And I think about 106. 106. Okay, then lastly, we have to measure angle T. So I am going to be moving my center of the projector to be right on top at the vertex, and I need to line this up so that the edges, the triangle side and the edge of the projector line up. Here we go. Okay, so now that they're lined up, I can measure, and it looks like, okay, I'm going to be using the outside numbers because outside numbers are going bigger. Just say you made a mistake and then you thought this was 140 degrees. Okay, think about it. If it's 140 degrees, this is greater than 90 degrees. This should be a bigger number, bigger angle than right angle. And it's not, it's acute angles. That means it has to be a smaller number than 90 degrees. So 140 is too big. The other one is 40, and that's the right one. And so I say 40 here. Okay, and check my measurement, and that's awesome. Okay, and next two are review problems of multiplying polynomials. How do I multiply 3x minus 5 multiplied by 4x minus 7. I first put my two numbers at the top and the second binomial on the side here, and then start multiplying. 3 times 4 is 12, and x times x is x squared. Negative 5 times 4 is negative 20, and then we still have an x. And then 3 times negative 7 is negative 21, negative 21x, and then negative 5 times negative 7 is positive 35. Then from here, I need to combine like terms, which are these, my final answer. So what's going to be my final answer? The x squared term is 12x squared. Okay, and then we have negative 20x and another negative 21x. So you add them together and you get negative 4. What happened here? I don't know what happened with my screen, but here are the answers after I combine the like terms. So 12x squared minus 41x plus 35, and you submit. I'm going to leave the next one for you to do. Okay, remember you need to put 5x plus 2 at the top and negative 3x minus 4 on the side here, and then multiply them out. Next up, I want you to explore this link that I am giving you, and that should send you to this link here. Okay, so this is a Desmos, and this is where you get to create any shaped triangle you want. You can create an obtuse triangle like so. You can move any of the points like so. Okay, and then once you've changed it, and then I want you to slide the slide. What do you notice? Okay, so whatever the angle, each of the angles, when you bring them together, what do you notice about that? They form a straight line together. When you add this angle, that was a pink one there, to over here, just move that, translate that and rotate it. And this angle here, if I just move that over there and put it glued it there, it forms together, it forms another forms 180 degrees. What if I changed it, change the shape? It still forms 180 degrees. Now the blue angle is much bigger, but the green angle is much smaller, and the pink angle is the same. Okay, so it doesn't matter what shape of a triangle is. What do you discover is that the angles, interior angles, the inside angles of a triangle will, when you sort of stick it together, it will always form a straight line, which is we know to be 180 degrees. So all the inside angles would add to 180 degrees. And that's what we call triangle angle sum. So the sum of interior angles of any triangle, no matter what the shape is, whether it's really skinny, tall, whether it's obtuse, whether it's all acute, or whether it's isosceles or equilateral, it will always add to 180 degrees. So what we're saying, the measure, whatever the measure of this angle is, plus this angle is going to be 180 degrees. So you can use the triangle angle sum to figure out what this question mark angle is. This is going to be 42 plus 125 plus x. If I call this, is going to be 180. So if I call this question mark angle x, then I can put as a statement equation that 42 plus 125 plus x is going to be equal to 180 degrees, that because they should all add to 180 degrees. That means 167 plus x is 180 degrees. Subtract 107 from both sides and you should get x is equal to 13 degrees. So I've just figured out the third angle measure of this triangle. Okay, and that is it for today. And so in the new table of content, you're going to be entering this. That's it for today.